You wanted to say something? No. Okay. Okay. Great. Uh, Hello again. So maybe you already caught it. My name is Goran Vuksic. I work as engineering manager at Pandora, leading the data infrastructure team. And I'm also Microsoft AI MVP. This recognition is given for sharing knowledge a lot, I would say, going out, holding sessions at different conferences, writing blog posts, contributing to open source community, and so on. That's something I like to do. And I like to approach technology in a playful way, figure out like what's possible to do with it. And I try to share that in different sessions. And this session today, we'll talk about gaze estimation possibilities in retail industry. Gaze estimation is figuring out where we look. It's a brand new session. I'm holding it for first time, so I really look forward to hear some feedback in the end, and hopefully you will have some questions so I can improve the session. I would like to kick it off with saying that we all like to think that we are unique and unpredictable. And that's not quite true. So especially if you work in some retail industry, you will try to figure out your customers and try to somehow group them in some categories or groups or something, figuring out what they need. It's not only retail, like for example, music streaming, right? You all use some kind of apps, and they try to guess some song that you will like, and compare you with some other users that listen to the same things, and give you some suggestions. And most likely, for all of you, it happened that you said like, "Oh yeah, this song was really great. I haven't heard it before. How this app knew that I could like it." So, but today we will mostly focus on the retail industry. And even though I work in retail, this is not something I do at work. This is a free time experimentation with technology to see how far we are and what we could do with it. So, talking about retail and predicting our customers, I'm pretty sure you at least once been in the maze. Maze is a concept of store where you go around different departments, from department to department, right? And you're there to buy something, but these stores lead you through, I don't know, taking you from living room into the kitchen, into the dining room, and then it triggers some kind of thoughts like, yeah, now I'm entering, I don't know, workroom, and the other day I missed something, you know, and I will purchase that. So without, this is examples without any use of technology. We'll get there. So what happens usually? It took me like 10 seconds to find example on the Twitter. You know, someone went there to buy 2 plates and 3 light bulbs, and got back with sponges, gloves, food, and no plates and no light bulbs, right? So most likely happened to some. And it's kind of interesting. Someone a long time ago figured out, okay, if people are put in these situations to go through some kind of concept, we will suggest to them that they could buy this or that, right? And similar thing, not all stores look like big mazes, right? Some of the small stores, you can notice on the cash register there, you have the some candy bars and some gums and such. This is mostly the historical reasons where we were using a lot of cash, and you had some coins, and then you were buying something, and you didn't want to carry those coins, so yeah, just give me 3 gums or 1 chocolate bar or whatever, right? So yeah, retail is using some kind of tricks, we should call it that way, but to suggest some things to their customers. And What about technology? I'm sorry if you don't see the titles, but mostly it's about pictures, and I'll explain. If we introduce technology to the whole thing, especially like AI, things could become scary, right? Actually, like lightning was scary many thousand years ago because no one understood what it is and how it works. But at some point we explained it how it works, and nowadays most of us are not scared of it. Okay, it's not pleasant when you see it and hear it, especially if it's close, but yeah, we all know how it works. And the same with technology. It shouldn't be scary if we know what's behind it, and yeah, what are the possibilities with it, and why is actually suggesting to us what it is suggesting. Just one scary thing, this slide, machine from 1967. Russian scientist called Alfred Yarbus made this machine and wrote a book called Eye Movements and Vision. It was published in Plenum Press in New York. You can find this book online. He was first one actually to investigate some things like about how we looking at different things. And he was using this machine. It's also scary to see the manual because you need to stretch your eyes to fit over here and such. But I guess in like 55 years ago, most of machines looked a bit scary. First thing he did is he was testing it with some people, like how do we read? And what he noticed is that we don't read at the constant speed. We don't move our eyes at the constant speed. We focus on specific words in the text, and basically jumping a bit from one word to another. Pretty good start. So he continued to figure out more about what we visually do. Here's one picture he used in his experiments with this machine. So he's from Russia. This picture is also from the artist Ilya Repin. Picture is called Unexpected Visitor from 1884. What is specific about this picture? Story behind it. This is the man who came home from Siberia after a long time. His family recognized him, but each one of them has different expression on the face. Some are happy, some are not, right? The thing that just happened since I showed you the slide. First time, when I showed you the picture, you had the general examination of the picture. Your eyes went through it. When I explained you what it is about, then you started positioning your eyes on specific features, right? And this is exactly what he explained in the book. Over here, you can see the free examination. This is approximately how we go with the eyes over the picture. I think it was done on the 10 recordings, like 10 different people like to figure out. He also used many other pictures that you can see. Then if someone asks you like, okay, give the age of the people, then you would position your eyes targeting the people, right? Or if you try to remember the clothes that are worn the people, you'll position your eyes in a specific way. Or trying to estimate how long the visitor had been away from the family, so something even more complicated. So the way you look at some things and having some thought in your mind will result in a different pattern. If I know that pattern, I could probably guess what you are thinking about looking at something. Are you just looking at the store window because you are passing by, or maybe something caught your attention over there and you are focusing on some details? Pretty interesting research. 1967, 55 years later, we use many modern technologies. And in retail industry, for example, what we are interested in is how our customers react to our products that are out there on the shelves, trying to understand their behavior. And with the gaze estimation, for example, in the store window, we could figure out some things like, okay, this is what is of interest, right? Their interest is over there. So this could also give us a hint, like maybe no one is focusing on this vase. We could move it away and put something else more interesting over there. Based on this, we could also suggest by the salesperson or by some in-store displays, like, okay, we have this on discount. Maybe you would like that. If a customer is focusing the view on in the store window, for example, on the red suit and red pants, maybe that person would like to buy red shoes also. Interest in some color, right? Doesn't take you to be a scientist if you know where the person is looking at. So for some demos today, I will use Luxonis OAK-D light camera. This is a high-resolution camera with depth vision and on-chip artificial intelligence. What does this mean? Is actually that this camera is capable of running the model, and it only gives you the data points. And mostly in general, like when we talk about AI, AI is going to the edge. We want to be able to run AI at specific places, to run it in the factory, at the factory line, detecting defects over there, and just sending data points to the cloud, like, okay, there's no defect on this product, but this product has a defect, so someone needs to react on that. And yeah, main reasons is you don't want to stream everything to the cloud. It takes a huge bandwidth. You know, even with the one camera, and imagine that you really want to use it in store and have 100 cameras over there figuring out your customers. Like, what kind of bandwidth would it require? So, pretty cool. It's pretty cheap, I would say, also camera if you want to experiment with it. But what's the best about it is they have a bunch of open source examples that you could just download and use. And some of those examples, before we go into live demos, like object detection, running on the camera, detecting like, here's the person, laptop, cat, some plants, right? Some more or less standard model. Running the edge detection works pretty great. For example, you can see by the holes on this shelf over here how detailed it is. It is stereo depth camera, so using two cameras like our eyes to figure out the depth. There is pose estimation, feature tracking, and many other examples that you can run out of the box. And we will be running one of those for the gaze estimation. So for the demo, first thing, okay, we want to clone this repository, GitHub Luxonis Depth AI experiments, and then when we clone it, we have gaze estimation as one example over there. What we need to do first is run pip install requirements, install the requirements locally, and then we can start this thing. So basically, I cloned the repository, and I install the requirements so I can start it immediately. I'll share the slides afterwards so you can check it out on your own. Camera is over here on the small tripod, just for me to be easier to handle it. You will see soon. This is the camera. Okay. So we are here. We need to run this command down here, right? So when we start the command, it will take a few seconds for the camera to boot up. At the moment, it is running the model for the gaze estimation. And let's see how it works. Right? You can see my eyes moving left and right. There are some other features we can turn on with this. This parameter cam is from camera, but you can also run it to use the video file, some stored video file to see that. We can also run it with parameter laser. So I'll be shooting lasers out of my eyes, right? Bunch of those examples that you can experiment with and have fun with. So, getting back to slides a bit. This is the gaze estimation. You've seen arrows. I've disabled this additional feature, so I'll explain them now, how it works. That is the standard gaze estimation, and this is with lasers. Okay, so this example is built on top of OpenVINO. OpenVINO is a framework developed by Intel. It is open sourced, and it is used to boost deep learning performance in computer vision, automatic speech recognition, NLP, and so on. And it uses models that are trained with most popular frameworks like TensorFlow, PyTorch, and more. You can check it out online, but pretty useful framework. And the way it works, over here, it's me in Azure SCON a few months ago, so I guess if I do like this, we'll have some Inception movie. We take an input image, and it will run in the background one model that is doing the face detection. So trying to find the face in that picture and cropping it out. Now what happens with that cropped face? There are two more models that are spinned. So it is doing landmark detection model, figuring where the eyes are and where the nose is. And based on that, it is cropping left and right eye. Then it does the head pose estimation. Those arrows on top of the nose are head pose angles. So where is my head positioned at the moment, where I'm looking at? Combining those two, cropped left and right eye and head pose estimation, it is merging this together with this gaze estimation model, figuring out the gaze coordinates. So where exactly am I looking at the moment? And those gaze coordinates are just a simple 2D coordinates. So if I look up, y will go to higher value, minus if I look down, same with the x, left minus, right plus value. So we have, we have two coordinates, and we can check it out in our demo. So let's take a look a bit at the code. Code itself, as I said, open sourced. The thing is, code is 400 lines. It's pretty simple, actually. But we will not go here line by line. I'll leave it completely up to you if you want to check it out, how it works. We'll focus just on some important parts. So I'll scroll down a bit to the part where it is figuring out these arrow lines. As you can see over here, it is drawing the arrow lines. In RGB, this is pink, right? Red and blue giving the pink lines out of the eyes. And over here, if we do print and we say that X, we want the value. Let me just find where it is here. We want value X. And we want Y. I save it. I run it again. And I made some mistake. What's happening? Let me try again, or is it typo? I don't see it. Yeah, it works. Okay, no idea what happened. So, as you can see over here, I'll try to move the terminal on the side. It's processing super fast. Like, okay, I'm now looking up. Y value should be above 0. Now, if I look down, it should be minus, right? And same thing with left and right. X value is changing. It's generating a lot of data. A lot of data is good, right? We all want a lot of data to be able to give to our data scientists to make some conclusions on top of it. But it is great how it's possible to spin the AI model here on the chip and give you the results immediately. So, we got results out. Now, we want to get them to the cloud. It's happening here, locally. We want to send it to the cloud to be able to store it, analyze it, do some other things over there. As I said, you don't want to stream the whole video and do things like that. You want just a simple data points, X and Y, like where this person is looking at. And if you know in that picture that person is standing at a specific point in store, or that example in front of store window, and if it's looking like at a specific side, you know what is over there based what you placed there. And in this case, I will treat my camera as any other IoT device, because there is no reason to treat it differently. IoT devices are the small sensors that are sending data to the cloud, like just small data points. And I'll do same over here, and I'll upload that data to the IoT Hub. IoT Hub, enables you to connect your IoT devices, highly secure and reliable, as Microsoft promotes it, and it is, and allows you some interesting things. And to the cloud, I want to send telemetry that will basically look like this. So some target where I'm looking at the moment. In order to use the IoT Hub, I need to install this Azure IoT device package for the Python. And now, not to make changes in that 400 lines of code go up and down, left and right, I have a separate example that will illustrate how this is done easily. Over here on the top, there is a link where you can find this SDK for Python, basically GitHub Azure IoT SDK Python. Will be shared later. What we do in this example, we import the required things. Then we need to connect, there's a mistake. This is just a connection string. We are not fetching it from the environment variable. We'll just paste it inside here to connect to IoT Hub to our device. So we say we create some device client, we wait for it to connect to IoT Hub, and we define message to send, just like I showed you. It's sending target X, target Y, and we will wait a bit for device to send this message, and that is basically it, right? So that's how it works. In the Azure portal, I have one resource group over here, and over here you can see I have IoT Hub that is called IoT Gaze Estimation. When I open this hub, on the left side, I have one option that is called devices. Here I can add my different devices, and I created the device that is camera 001. Adding device is super simple. Basically, you need to just enter the device ID, camera 002, and click save. So you can you edit over there. There are just a few options here. So no magic in adding devices, and once device is here created, you can open it up, and you can see this ID. You can see the keys, and you can see the connection strings. So this is the connection string I will use in my code. Looks like this. If you unhide it, I will copy that. Save here in my code. Go back here, and this is called main demo. When I execute that, yeah, sorry. Problem with the top of the screen. Okay. When I started my main demo, basically it went connected to the hub, wrote out sending messages successfully sent. I just had this one messages. So basically it went through, take the connection string, connected to the IoT hub, and prepared the message and sent it over. Okay, so we got the message out there sitting in our IoT hub in Azure. So what can we do with that? There is one great thing that is called stream analytics. And stream analytics allows you to create a job. In stream analytics, you define the input and the output. And in the middle, you define some function how you want to transform this data. For example, over here, I have an input that is pointing to my IoT hub, IoT gaze estimation. I could define some other inputs like event hub or the blob storage beside the IoT hub. And for the output, I can define many different things. I can store this data to database, or I can send it somewhere else. So there are many options for that. And here in this query part, when it loads in a few seconds, hopefully, it is trying to catch the data from the hub. And over here, we will see the preview of our message, right? Target 1010, right? And over here, here with the query, we can do different data transformations and send it over to our destination. What it means is that we would be able to build a solution end-to-end, where we have our camera figuring out where our customers are looking at, sending data to IoT hub, using stream analytics to send it forward, for example, storing Cosmos DB or wherever you want to store it, sending it to machine learning for some real-time predictions, being able to suggest our customers in real time some things, using the Power BI, for example, to give some overview and analytics, maybe for the um, salesperson working in a store, figuring out like, okay, today I changed the layout of the store, but people are not focusing at this part of store at all. Maybe I should put something there on discount or whatever there is. And with this, we could suggest our customers something like putting some messages, hopefully not too aggressive out there, so they don't have a feeling they're under the a huge light. We are looking at them or something, but maybe something like, we noticed you like blue clothes, and we have a blue jacket at 10% discount. So trying to make them happy. It's never about sales, we say. It's always about making them happy, and yeah. But just an example how this end-to-end solution could look like. Okay, so thank you. I hope it was inspirational, because that was the idea, to inspire you a bit, like how this kind of technology can be used, to show you how easily it can be used. Like I said, not only camera out there, there's a bunch of them you can try out and get the same results. So, any questions? Yeah.
How hard would it be like to transfer that data to database to calculate, for example?
You can take it from the with stream analytics, and does it allow direct integration? I don't. It does. Okay. Okay. I never tried that, but yeah, with stream analytics you can transfer it, like I showed, for example, to machine learning in the real time, or to store it somewhere, and you could send it to Databricks. Yeah.
Thanks a lot, first of all. This example was now with one person, but in a boutique, usually we have more people.
Let's give it a try.
Yeah.
While we're on that, I can add, so the chain there from camera to IoT hub to stream analytics and then to XYZ. If you have that connected, it could be near real-time setup. So as Goran now is looking, lasers shooting out, all of that could be near real-time presented in a Power BI dashboard, for example. So you would quickly be able to see what's hot or not.
Obviously, what happened now is that it's trying one by one phase to estimate, and goes around in a loop in the picture. So this example is not optimized for the multi-person, as we can see, but we could do that.
Then we could get where most people look at, or where all of them look at. What would we estimate if we have a group?
Each person separately. We would take each person separately and trying to create some kind of heat map, like this. You know, there's some, I don't know, fruits in the store, and people are passing by. Several people are looking at some fruits. Some are looking at apples. Some at bananas. Yeah.
Okay. Okay. Thanks.
The last example you had there, that was more for like the blue jacket. That would be for a single person, right?
Could be for multiple persons. If we figure out that out of 20 people in the store, 10 of them are mostly looking at the blue articles, why not put that up? Could give them some ideas. Yeah. But still, keep in mind, this is simple example. If we get back to that research 55 years ago, if we know the patterns, how people look, we could answer some questions back. We could figure out much more stuff, not just this. red, blue, green, whichever color the person is interested at.
Yes, thanks for the presentation. I have a comment and then a question as well. Actually, I did my master thesis on gaze directed cameras, and that's
Great to hear.
15 years ago. And the camera we had to use back then was 50,000 or something like that. And now you can buy it for, I guess, a couple of hundred.
Yeah.
So a lot has happened, obviously. Anyways, my question is, can you run your Python on the camera, or do you need a separate device that is connected to the camera? I don't know if you know for this specific camera.
To be honest, I'm not sure. I would need to check
Okay.
documentation a bit deeper, like how
Yeah.
to do that. Yeah.
Because it would be cool if you could have it all in
Yes,
one box.
Standalone,
Yeah.
fully standalone, just a charger out there, and
Yeah.
that's it. Yeah, definitely. I would need to check that. Yeah, good question. Hmm.
Thanks for the presentation. I have kind of a stupid question, but could it be
No stupid
combined
question.
with maybe other face recognition models? Because somebody might look at a shirt a lot, but they might look at it because it's ugly. So, you know,
Yeah.
see if they smile.
Yeah, that's also the thing we could use. There are models for the emotion recognition, so you could figure out, okay, is someone happy about it or really angry about it, or looks bored, and take this and make it even more complex. The thing is, like, when we use the camera, even though, you know, that this is X amount of pixel by, you know, some width and height, and we are analyzing a certain number of pixels, but there are so many things regarding the people that we can analyze, from the, you know, body position, emotion, gaze estimation. There's a lot of things. And yes, of course, more of those things you are able to get data about, then more we can extract out of it, make our prediction algorithm smarter. That's what our data scientists do.
No more question? I guess it's thank you then, Goran. Always
Thank you.
interesting.